The domain of a function is all the possible x values that satisfy the function, that work in the function, all the possible input values that will give you output values. And when we see x's in the denominator of a fraction, we need to think undefined. X can't be whatever results in an undefined fraction, 0 in the denominator. So for our first fraction, we see that it is x minus 2 in the denominator. And so that means that x cannot be positive 2. Because if x were positive 2, we'd end up with 3 over 0, which is undefined, and we cannot have that. So in this case, and as usually is the case when it comes to fractions, it's easier to say what x can't be than what x can be, because x can be every number except 2, except positive 2. And so it's easier to point out the one number x can't be instead of the infinite numbers that x can be. And the same thing for our second example to the right, x cannot equal negative 3. X can be any number except negative 3, because that would result in undefined. When it comes to square roots or radicals, we're not so much concerned with 0 as we are with negatives, because we know the square root or the radical of a negative number. Well, I shouldn't say radical, because a cubed root works, but here we're just dealing with square roots. We can't have the square root of a negative number because that's imaginary. So we want to know what values of x will give us imaginary, what values of x will give us real answers. And this is one of the cases where it's probably easier to say what x can be than what x can't be, because we're going to deal with some inequality signs. But for these, there's a couple of methods to go, but I find it's best to kind of just take a look at it, plug in some values, and see what happens. Like if we were to plug in a 1 for x, we'd end up with the square root of 2 times 1 is 2, minus 5 is negative 3. So x can't be 1. If we plug in a 2 for x, we'd end up with 2 times 2 is 4, minus 1 is 4 minus 5 is negative 1. So we get x cannot be 2. If you plug in a 3 for x, you'd end up with 2 times 3 is 6, minus 5 is positive 1, which does work. And so what this tells us, since 1 doesn't work, 2 doesn't work, but 3 does, x has to be greater than or equal to 3. Otherwise, we'd have imaginary. So your domain is all values of x greater than or equal to 3. And that's different than here, because up top for the fraction, we're saying what x can't be. For the radical, we're saying what x can be. So sometimes it goes back and forth. And our other radical here, you see if you plug in a 4, you'd end up square root of 0, which is okay. If you plug in, a negative 4, sorry, that's actually what I wanted to do the first time. If you plug in a negative 4, you get 0, which is okay. If you plug in a negative 5, you'd end up with a square root of negative 1, so that doesn't work. So that means x has to be greater than or equal to negative 4. And you could try a few more numbers to confirm that negative 6 doesn't work, negative 7 doesn't work, negative 4 does, negative 3 does, negative 2 does. It has to be greater than or equal to negative 4.